In math class, teachers wrestle with this tension: conceptual understanding versus procedural fluency. And now, with AI in the mix, the gap between the two is even more exposed. Because AI can give students every step, explain every method, and walk them through any solution in seconds, but it cannot make them understand what's happening. And it definitely cannot make them care. So today's episode is all about getting students to do both: understand the why and execute the how with the support of AI, but without letting it take over. Let's take a look at what this looks like. So you want to start with a story and not a formula. If you want students to understand math deeply, ground the concept in something real. Instead of starting with "today we're learning how to find the area of a trapezoid," start with "imagine you're designing a ramp for a skate park. The surface has to taper safely between two heights. How do you figure out how much material to use?" This activates intuition and curiosity, and it gives students a reason to care before introducing the rules. Then ask students to explore the concept with AI as a guide. Have students prompt their AI with examples like, "explain the concept of slope like I'm in the fifth grade. What's a real world situation that uses the Pythagorean theorem? Give me 3 different ways to understand standard deviation." Then ask the students, which explanation helped you most and why? What's still unclear? How do these connect to what you already know? They are not just receiving answers, they're building conceptual bridges. Require comparison and analysis of multiple procedures. Once students understand the idea, have them explore additional methods. Have students ask AI for 2 different ways to solve this type of problem, or to compare the steps. Follow up with which is more efficient, which makes more sense to you. Then have them solve it without help while annotating their steps and explaining why they chose that method. This keeps AI in the role of tutor, not substitute. Embed AI into the practice and not the product. When assigning procedural practice, shift from "solve 10 problems" to "use AI to generate 5 similar problems. Solve 3 of them and explain which was the hardest and why. Have AI solve the other 2, then critique its process." Now you're teaching flexibility, precision, and confidence. Introduce real world synthesis challenges. For example, you're designing a school cafeteria and you need to figure out optimal spacing between tables using area, perimeter, and ratios. Use AI to research examples, but you must make final calculations, justify them, and reflect on your process. The thinking and justification on the student. AI supports research and not replacement. Flip the problem solving role. Instead of always solving problems given to them, ask students to write their own problems, then prompt AI to solve them. Evaluate the AI solution, compare it to their intended answer, and reflect on how the concept was applied. Now they're operating at the designer level. Cheating here? Not so easy. There's too much critical thinking involved. Use multi-part tasks that demand concept and procedure. You can structure your assignments like this. Have a conceptual warm up where you ask, "what do you understand about linear relationships?" Or use AI to help explain what a constant rate means. Then you transition to procedural practice, where you ask students to solve these 3 problems by hand and show your work. Then the application task, where you ask students to create a visual or scenario that shows this math in action. Finally, have students reflect on where they struggled and how AI helped them get unstuck. Every layer serves a different cognitive function, and that's what builds real math learning. Build a rubric that values the process. Try this: 30% for conceptual clarity, journal reflections, AI comparison; 30% for procedural accuracy, correct steps, justification; 20% for real world application or synthesis; 20% reflection on the learning and the AI interaction. This tells students you are not just being graded on the answer, you're being graded on how well you understand, communicate, and reflect. Show students that math is about thinking, not just solving. Use sentence starters like, "at first I thought XYZ," or "AI explained it like this," or "now I realize, I still have questions about." You're helping them narrate their journey, and that's what makes the learning visible and authentic. We need to use AI wisely to bring thinking front and center. Let AI explain, let it clarify, let it challenge. But then let students own the reasoning, the steps, the decisions. Because when we combine concept and procedure, intuition and execution, curiosity and precision, we are not just teaching math, we're developing mathematical thinkers, and that's something AI can never replace.